Okay, so we need to separate the variables. We're going to take this guy and we got to move him to the right side by dividing him. So it would be y minus 1 dy equals, and then we're going to keep the 2 sine x on the right, and then we're going to multiply the dx to the other side. In this numerator, I should have a 1. Are we doing okay on that part, Cynthia?
Yep.
Okay, perfect. So the next step is to integrate both sides, right? I'm going to throw that integral in between my 2 and my sine x because I'm allowed to pull the 2 out front. Technically, there's a u substitution, but, okay, this would be the u, right? So u equals y minus 1, which means that du equals 1 dy. So they're really, we can kind of, in this case, ignore the u because the coefficient in front of our y is a 1. So it acts like just a 1 over y, okay? The difference is that instead of it being natural log of y, it's going to be natural log of y minus 1. So technically, yes, there's a u sub. In this case, I usually tend to just ignore it. So when I integrate that, I get natural log absolute value of y minus 1 equals, and then we integrate sine, we get negative 2 cosine of x plus c. Are we good so far?
Yes.
Okay. There are 2 ways we can go from here, okay? We can either plug in right now and try to solve for our c, or we can plug in later and try to solve, or we can try to solve for y and then plug in. I'm not sure what's the better way to go. I'm going to try to just plug in from here because it's going to make the trig kind of go away and make it more numeric, and then we'll only have to deal with the natural log to solve. So that's where I'm going to go with it. Although it does say we have to do y equals at some point. So let's see how it goes. We're going to go ahead and plug in the negative 2 for the natural log. And we're going to plug in the pi over 3 for the cosine. And our goal is to solve for c. So let's see, I'm seeing negative 3 in there, and then the absolute value of it is 3. So natural log of 3 equals, and then if I pull out my good old unit circle, let's see, pi over 3 is up here. I'm out 1, up 0, so 1, 2, 3. So it's got to be 1/2, which is actually kind of nice. So negative 2 times 1/2 plus c. That was very nice of them to do that. So I have a negative 1 plus c equals the natural log of 3. And then, so it's the natural log of 3 plus 1 equals c. I'm going to take that and put it into here, and it's just big ugliness is what it is. I don't know what let me go back to Delta Math real quick. Let's see what they're doing, looking at for their answer. Apparently level 2 really amped it up, huh? Okay, that was not my intent, was to really amp it up. Let's see what they did. We got the same thing there. They plugged in the point. We got the same thing. Okay, it's as ugly as what they intended. We're on the right track. Okay, so I'm going to go ahead and plug my c into this line right here. Oh, not that line right there. This line right here. Okay, so that's where c is going to go, and it's going to just be as ugly as it is going to get. I'm going to put it to the left here, though, because that's where I have space. So natural log absolute value of y minus 1 equals negative 2 cosine of x, and then I'm plopping this in for the c. So plus natural log of 3 plus 1. All right, and then in order to get rid of the natural log, we're going to exponentiate it, which I could at this point probably just drop my absolute values. E to the negative 2 cosine x plus natural log of 3 plus 1. These cancel. We've got y minus 1 equals this mess. And I don't know, I'm going to go back and look here in a minute and see how far they simplified that. And then we're going to add the 1 to the other side. Cosine x plus natural log of 3 plus 1 plus 1. Let's see, where did they go with it? They left the mess in the numerator, or in the exponent, sorry. So that's got to be our final answer. Are we doing okay, or did I go too fast?
No, it's fine.
Okay. Do I need to do another one? Or does it make sense now?
Yeah, can you do a fraction one?
One that has a fraction? Okay, let's see what delta math gives us here. All right. Let's see. Go to show question. Tell me, tell me when you see one that you like. Is it that one?
No.
Okay. That one's about this. Oh, I said show question. I hit the wrong problem. New problem. I've got a secant squared.
No.
No. Okay. Another secant squared. I'm going to keep going. That one?
No.
Yes or no?
No.
No? Okay. That one?
Yeah.
Okay. Let's do that one. All right. So this one probably, it seems worse than it is. This one's actually, those other two that we just skipped over were probably worse than this one. But it's okay. Once you see this, it's not hard. I think that we would be thankful to get one like this, I think, if we saw it. All right, here we go. So I'm going to start by separating my variables just like I did before. So the y cubed, I'm going to take to the other side by division. So we know that there's always a 1 on the top. We're going to keep the dy. I have a 4 over x squared, and I'm going to multiply the dx to the other side. So our variables are separated. We're now going to integrate, and I'm going to rearrange this before I integrate. I have to bring this upstairs as a negative exponent. Remember, when we're integrating with the fractions, it's 1 over something to an exponent of 1 is natural log. Everything else, you have to bring the exponent upstairs. Okay. All right, and then this one is going to be the same as saying I'm going to put the 4 on the outside, x to the negative 2 dx. Now we are ready to integrate. So we're going to add 1. So we get y to the negative 2 divided by negative 2, 4x to the negative 1 divided by negative 1 plus c. I'm going to, before I start plugging anything in, I'm going to go ahead and simplify a little bit more. So I'm seeing negative 1/2 with a y squared on the bottom equals negative 4 over x plus c. And again, we have choices. We could try to solve for y now, or we could do that after we plug in. I'm going to go ahead and plug in first. So I'm going to plug this guy into there. So let's see, we're going to do negative 1/2, and we're plugging in 1 for the y, so 1 squared equals negative 4 over 2 plus c. So this is negative 1/2. I'm going to leave this in halves because I'm just going to, if I simplified it, I would just have to scale it back up. I'm going to add that 1/2, or so I'm going to add the 4 halves to the other side, which will give me 3 halves is c. From there, I need to go back to this line right here. Actually, I'm going to go to this line right here. The line before you plugged in, right? And I'm going to plug my c into that, which was the 3 halves. So negative 1 over 2y squared equals negative 4 over x, and then it was plus 3 halves. Our goal now is to get y by itself, okay? So let's see, we're going to, so in order to get this out of the denominator, let me see what they did. I know how to do it, I just want to make sure I'm guiding us to the right solution here for you. Okay, they left it super ugly. Nice. Okay, let's leave it super ugly. All right, we're going to multiply by this mess to the other side. So all I'm doing is following my good algebra steps. So 4x plus 3 halves, I'm going to put that in parentheses, times 2y squared. In fact, I'm going to rewrite this a little differently. I'm going to write this as 2y squared. I am now going to take everything that's not the y, so all of this, including the 2, and I'm going to divide by it. So I've got negative 1 divided by this giant mess. I'm going to put the 2 on the outside. plus 3 halves equals y squared. And then we're going to square root both sides. So square root of -1 over 2 times -4x plus 3 halves equals y. And then because our point, I'm going to guess that there's a plus minus thing. Our point is out 2 up 1. So we know that that's going to be positive all the time. We don't do plus minus. It would just be plus. And that's the nature of where our point landed. Okay. Is that better? And it looked like they left the answer messy like that.
Yeah.
Okay. Are there any others?
Can you do one that has an E in the denominator?
An E in the denominator, sure.
With like an exponent of x?
An exponent of x, let's see, an E in the denominator. Keep going. That's an E in the numerator. That one?
Can it just be EX?
EX? Okay, let's see if we can find one. That's an EY, EY. Eventually, if we hit it enough times, we should run across one. Like that, maybe?
Yeah, kind of like that.
Okay.
But like the 2y has to be an x.
Okay. Let me keep going. Oh, sorry, I hit the wrong button. Was that in the level 2 or was it in the level 1?
It's in the level 2.
Okay. I am not running across one. Okay, why don't you just read me the problem, because I seem to not be running across one.
Okay.
So dy dx equals
Y cubed over e to the power of x.
That's it?
Yeah.
Okay, so we're going to take and separate our variables. So the y cubed is going to get divided to the other side. And then we get 1 over e to the x, and the dx is going to get multiplied. So now we're ready to integrate. And we're going to bring these up using exponents, okay, or negative exponents. So we've got y to the -3 dy equals e to the -x dx. So this one's not bad. I add my 1. So y to the -2 divided by -2. This one here is going to need a u substitution. So u equals -x, meaning that du equals -dx. We have the dx, we need the -1. So technically it's like that, right? The -1 in the denominator, which is still just a -1. All right, so let me rewrite with the u's. So we've got -1, the integral of e to the u, and then for the -1 dx, we get du. All right, the right side, when I integrate, I get -e to the u plus c. And then we substitute our u back in. On the right side, I'm going to bring the y back downstairs. So it's going to look like that. All right, and again, I can either try to solve for y or I can plug in. What was your point?
It was y0 equals 1.
Okay. So I'm going to put 1 in for the y, which is just going to make this -1/2. That was very nice of them because anything to the 0 power is 1. So I'm going to write that in halves. So we've got -1/2. We're going to add 2 halves, which is going to make it +1/2 equals c. And then I'm going to go into the line before I substituted. So I'm going to go into here. I'm going to plug the C in. So we get 1 over negative 2y squared equals negative e to the negative x plus 1/2. And then we're going to multiply by the denominator. So we get 1 equals this mess times negative 2y squared. And again, I'm going to use this little trick. I'm going to divide by all of this. So 1 over negative e to the negative x plus 1/2 times negative 2. And then again, we're going to take the square root. It would probably just be positive again because of our coordinate. So y equals the square root of 1 over negative e to the negative x plus 1/2 times negative 2. The ones I do on the test are probably going to be more like what you see in the level 1s. This is a little bit messy for us, and even a little bit messy for AP. Okay, how's it going?
Good.
Good. Okay, are there any others you want me to do?
No, I think I'm good.
Okay, sounds good, Cynthia.
Thank you.
You're welcome. I'll see you later.
Okay.